Okay, in this video, I want to use Desmos to show you some left-hand, right-hand, and midpoint sums. So I'm here on the class website, just so you can see how I'm getting here. I'm going to click on Handouts. These aren't actually handouts, these are just links, but that's where I put them, under Handouts. And you'll see this note here under 5.1. Professor Jonathan Luque, who teaches at Saddleback, created these graphs, and he was kind enough to share them with me and allow me to share them with you. So just wanted to give a shout out to him, to thank him for creating them. I'm going to click on Desmos now. So you can see we're looking at f of x equals x squared. And there are these two sliders. There's one for b. So right now b is 2. I can change it. Okay. And basically we're integrating from 0 to b. So the left endpoint of our interval is always 0. We can change a little bit what the right endpoint is. We can make it anywhere from 0 to 10. Okay. The slider that I think is more interesting is n, which is the number of rectangles. Now you'll see up at the top, this is right Riemann sums. So you can see for each of these subintervals, we've selected the right endpoint and the height at the right endpoint to be the height of our rectangles. Now just watch what happens as I increase n. So I'm getting more and more rectangles. And you can see the area that we're getting is getting closer and closer and closer to the actual area that's between the curve and the x-axis. So that's pretty neat to see. Now he's got 3 links up. That was with right endpoints. So here we've got the same thing but with left endpoints instead. And you can sort of see because this curve was increasing as we go up, when we chose right endpoints, we were always choosing the highest point in the interval, so we were getting an overestimate. When we choose left endpoints, we're choosing the lowest point in each interval, so we're getting an underestimate. But if you look at what happens as n increases, those gaps of that missing area seem to be shrinking. This is getting awfully close to the correct area. Okay. And this is only allowing us to go up to 50 rectangles. Imagine if we went all the way to 1,000 or 1,000,000, or took the limit as we go off to infinity. Oops, I think I clicked on the wrong thing. I wanted to go to midpoints. So for midpoints, we've got the same subintervals here, but you'll notice we're taking the middle x value as our representative x value, and then extending the height to the left and to the right until we cover the entire interval. Okay. So once again, if I let n go towards 50, the area that we're getting looks closer and closer and closer to the actual area. Now, of course, we know we're ultimately going to be taking the limit. So n isn't just going to 50. We're going to take the limit as n goes to infinity. But this really helps to illustrate how we do get closer and closer and closer when we chop things finer and finer and finer. So these links are available on the class website. So if you want to play around with it a little on your own, you're certainly welcome to do that.